You're standing in a forest. It's roughly 200,000 years ago. You're hungry. Not, I'll grab something from the fridge, hungry. The kind of hungry where your body is starting to eat its own muscle tissue for fuel. There are berries on that bush over there. Some kind of mushroom growing on a fallen tree. A root sticking out of the ground that might be edible. Some of these things will nourish you. Some will kill you in a way that is genuinely unpleasant. We're talking liver failure, hallucinations, seizures, a slow death over several days while your organs shut down one by one, and you have no guidebook, no app, no grocery store. No one has ever written anything down because writing won't exist for another 195,000 years. So, how did you know? The honest answer is, you didn't. Not at first. Somebody had to eat it first. Somebody had to be the test subject. And the fact that you exist right now, reading this, means that enough of those test subjects survived to pass on what they learned. This is the story of how humans built the most important database in history, without ever writing a single word. Your body came pre-installed with a basic food safety system. It's not perfect, but it kept enough people alive long enough to figure out the rest. Bitterness. That sharp, unpleasant taste that makes your face scrunch up involuntarily. That reaction isn't learned, it's hardwired. Because in nature, bitterness frequently correlates with alkaloids, compounds that plants produce specifically to discourage animals from eating them. Many of these alkaloids are genuinely toxic. Human infants demonstrate this from birth. Before they've ever been told what's good or bad, before they've had a single lesson about nutrition, a newborn will reject bitter substances. It's one of the oldest survival mechanisms in the human body. Sweetness is the opposite signal. In nature, sweetness almost always indicates calories. Ripe fruit, honey. These are energy-dense foods, and your brain is wired to pursue them aggressively. This is why sugar is so difficult to resist. Your brain still thinks sugar is rare and precious. It has no idea about the cereal aisle. Then there's smell. Every time you sniff milk before pouring it into your coffee, you are using a food safety system that is older than language, older than fire. Your nose can detect bacterial decomposition, fermentation, and chemical changes that your eyes can't see. It's not foolproof, but it's the first line of defense. The problem is, these senses have limits. The death cap mushroom is by all accounts perfectly pleasant tasting. Slightly nutty, mild. Nothing about its flavor warns you. Your sense of smell won't help either. It looks like several edible species. It tastes fine. And then, 6 to 12 hours later, it begins destroying your liver. By the time symptoms appear, the damage is already catastrophic. If ancient humans had relied only on their senses, they would have died in numbers that would have threatened the survival of the species. They needed something more. They needed knowledge that could be passed down. They needed culture. What ancient humans built was, functionally, a database. A living, breathing, constantly updated cultural database, stored entirely in human memory and passed from generation to generation through direct teaching. Indigenous communities around the world have been studied extensively by ethnobotanists, and the results are staggering. Individual people who can identify between 300 and 1,000 different plant species. Not just identify them, know which parts are edible, which are toxic, which are medicinal, which are seasonal, which require processing, and which can be eaten raw. A single elder in an Amazonian indigenous community may carry more working botanical knowledge than a university-trained botanist, not because the botanist is less intelligent, but because the elder has inherited thousands of years of accumulated, tested, verified knowledge, passed down through an unbroken chain of oral tradition. Ancient humans didn't just randomly eat things and hope for the best. They developed systematic testing protocols that were remarkably sophisticated. First, observe. Watch what animals eat. If a bird eats a particular berry and doesn't die, that's a data point. It's not conclusive. Some animals can tolerate toxins that would kill a human, but it's a starting place. Second, external contact. Rub a small amount on the skin. Wait, if there's a reaction, redness, burning, swelling, stop. That's your answer. Third, oral test. Place a tiny amount on the tongue. Don't swallow. Wait. If there's numbness, burning, or an intensely bitter taste, spit it out. Fourth, small ingestion. Swallow a very small amount. Wait several hours. If there are no symptoms, no nausea, no cramping, no dizziness, proceed. Fifth, gradual increase. Eat a slightly larger amount. Wait again. repeat over days or weeks. This process is slow, it's cautious, and it's remarkably similar to modern pharmaceutical testing protocols. Phase 1, Phase 2, Phase 3 trials. Ancient humans invented clinical trials tens of thousands of years before the concept had a name. Here's where it gets genuinely impressive. Cassava. One of the most important food crops in the tropical world, feeds hundreds of millions of people today. Also contains cyanogenic glycosides, actual cyanide precursors. Eat raw cassava and you're ingesting hydrogen cyanide. But indigenous communities in South America developed a multi-step processing method, peel, grate, soak, squeeze, cook, that removes the toxins completely. Nobody in the ancient Amazon knew what a cyanogenic glycoside was, but they developed a protocol that handles the problem completely through generations of careful observation and accumulated knowledge. Acorns are another example. Calorie-dense, abundant, storable. Also loaded with tannins that cause nausea and interfere with nutrient absorption. The solution? Crack, grind, and soak repeatedly in running water for days or weeks. The tannins leach out. What's left is nutritious flour. These aren't random discoveries. These are multi-step processing protocols that had to be developed, tested, refined, and transmitted accurately across generations, all without writing. Children in ancient societies didn't learn what to eat the way modern children do. There was no separating mealtime from education. They were the same thing. From roughly age 3 or 4, children begin accompanying adults on foraging trips. They watch. They're shown which plants to pick and which to avoid. They're told stories, often with vivid, memorable consequences, about what happens when you eat the wrong thing. By adolescence, they can identify hundreds of species. They know seasonal patterns, growth locations, preparation methods, and medicinal uses. This isn't casual knowledge. This is a working expertise that took a decade of daily immersion to build. There's a genuine evolutionary puzzle about human menopause. Most animals remain fertile until they die. Humans don't. Women can live decades beyond their reproductive years. Why would evolution preserve that? The grandmother hypothesis offers an answer. Postmenopausal women were frequently the most knowledgeable foragers in any group. They had decades of accumulated experience. They knew which plants fruited in which season, which roots were safe during drought, which preparation methods worked for which toxins. She was a library, and when a library burned, when an elder died before passing on her knowledge, information could be lost permanently. Entire categories of food knowledge gone. During famine, the rules changed. People ate things they would never eat otherwise. They experimented out of desperation, and sometimes those desperate experiments revealed new food sources. Clay eating, geophagy, likely emerged during famine. People ate clay to fill their stomachs, and some of them noticed that certain clays reduced nausea, settled their stomachs, or made otherwise irritating foods tolerable. We now know that specific clays can bind to toxins in the digestive tract, effectively neutralizing them. Ancient humans discovered this through desperate experimentation. Famine was the R&D department of the ancient food system. It was brutal, it was costly, and it produced discoveries that fed countless generations afterward. This system worked, but it was not free. People died building it. Food poisoning was a significant cause of illness and death. Some experiments ended badly. Some knowledge was lost when the people who held it died too young. Every food you have ever eaten exists in your diet because somebody, somewhere, at some point in the last 200,000 years, put it in their mouth first and survived. The entire modern food system, every apple, every grain of rice, every cup of coffee, sits on top of an ancient knowledge base that was built through trial, error, suffering, and an extraordinary commitment to making sure the next generation knew what the last one had learned. You didn't have to figure out which mushrooms would kill you. Somebody already did that, and it cost them everything so you could have lunch.